All right, let's get going. Welcome back. Good to see you. Hopefully, have a good little day so far. One of your last classes. Really good. Couple last days for you seniors out there. Make sure I've signed your sheet before you go. But I want to kind of continue where we left off yesterday. And make sure that all that stuff from yesterday that's still up right there still makes sense to you. I know you go through 5, 6, 7, 8 classes a day, so I know it's a lot. So I want to make sure that some of this comes back to you. So we're actually going to start class with practice rather than like learning something new and then practicing that. So take us on the right way, something to write on, jump right back in. Nothing you have to submit. I just want you to have this for yourself. I'm going to make up some new ones that are similar to, but a little different than that. But the same style. First two will be really nice, like 4 and 5. Second pair will be not nice, nothing we can do besides pull out the eye, like 6 and 7. And then the third pair will be like 8, 9, where it's not a perfect square, but it does have a nice one that goes in. Okay? And I want to make sure that this idea gets locked in today, because tomorrow, when I'm not here, okay, you're going to have classwork that has these kind of questions on it, and I want you to be able to knock those out quickly. Okay? So I'm going to make 6 more. Okay? 1, 2, 3, 4, 5, and 6. Write these down in your notes somewhere, wherever you want. Where you kind of use the stuff that we did yesterday to help you out. Okay, so x squared equals, let's go to negative 100. X squared equals negative 1. X squared equals negative 35. X squared equals negative 23. X squared equals negative 18. And x squared equals negative 125. Again, nowhere to submit this today, but you will have something to submit tomorrow in my absence. I'm not sure who's going to be here, but they might just be a sub, like not a math person. So you want to make sure that you've got these ideas down today so that tomorrow is an easier day for you. Okay. In case your teachers haven't said anything, no homeroom tomorrow. We have a regular schedule. Wednesday tomorrow is exactly like today's schedule. You do not have the shortened classes with the homeroom. Okay, first is at 7:40, second is at 8:30 or whatever. 7:40, 8:35, 9:30, 10:25, 11:15. Nothing changes from today to tomorrow, which I think is just because seniors last day, so or last couple days. All right, so I'll give you a few minutes to try these out. Look back at the work from yesterday. If you need some guidance, right? 1 and 2 are going to be like the first two. 3 and 4 like the 5 and 6 like those. And practice to start, and then I've got some stuff to show you for what's coming next with these complex numbers, right? What we're doing now is solving equations with complex solutions. What we'll get to is, all right, well, what do we do with complex numbers once we go? All right, give them a shot. Give them a shot. Really, like 1 or 2, maybe 3 steps at the most, depending on what you got. Good. The glare isn't too bad, so you folks at home can see that. Give it a shot. Let's see who we got today. And we'll do the same thing we did yesterday. Anybody that wants some extra credit will have an opportunity to do so. Anybody that didn't get a chance yesterday, you will have a shot at it. And then everybody. In case you want. Basically 3 points. So whatever works. Let me know if you have questions during or once we go over them. Stands out. Yeah.
I have a question.
Sure.
So, how do you know when you should break it into feet? Like, how do you know when's the right time to do that?
If there's a number that goes into it, that's a perfect square. 4 is a perfect square because the square root is nice. 9 is a perfect square because the square root is nice. 16, 25, 36, all those kind of numbers have a perfect square. And so like 6 and 7, right? You look at 13. Think about the ways to multiply the 13. Are there any ways to multiply the 13 that have a perfect square factor? Well, the only way to get to 13 is 1 and 13. That doesn't work. Same thing with 21. The only way to get to 21 is 1 and 21. That doesn't help you because 1 is, I want to make the numbers small. Is there another way to multiply 21 besides 1 and 21? Right. And so, but think about those numbers. Like, sure, 3 times 7 is 21, so I could split it apart. But is the square root of 3 nice? Is the square root of 7 nice? So there's no point. I'm actually making it more complicated by splitting it into 2 rather than just leaving it as 1. But look at like number 8 here, 24. 24 is not a perfect square, but how do you multiply the 24? Well, 1 and 24, that's not going to do anything, so keep going. Does 2 work? Does 2 go in? 2 times something? So do 24 divided by 2. So 2 times 12. But are either of those perfect squares? And I think no, so I don't want to use that. What about 3? Does 3 go in? 3 times. Let's do 24 divided by 3.
8.
So 3 times 8. But is 3 a perfect square? Is 8 a perfect square?
Is it a perfect square?
Can you take the square root of 8 and it's 9? No. So I don't want that. Does 4 go in? 4 times something being 24? 4 times 6. Now, why do I like 4 times 6, but I don't like 3 times 8 or 2 times 12? What's the square root of 4? Perfect. And that's what I want. If I'm going to make the plan to split this apart, the only reason I would ever want to do that is if there's a perfect square that goes into it. Because now I can, oh, okay, square root of 4 is 2. My numbers get smaller, and I can simplify one of the square roots. Same thing with 48. 16 times 3 gets me in. Now, sure, 2 times 24, right? 4 times 12. There's a lot of different ways to get to 48, but the one that has the biggest perfect square is 16 times 3. And by splitting it up like this, I can do the square root of 16 separately. Bring that down, bring this down, bring that down. All right, so when I think about like trying to do something like, the square root of negative 35. How do you get to 35 by multiplying numbers together? Well, 1 and 35, I don't care about that. It's not that big. He doesn't do it. 4 doesn't do it. 5 times 7 is 35, right? But is 5 a perfect square? 7 a perfect square? That's kind of what I want. Down, brother. Like as much as I want to split 35 apart, none of my factors are perfect squares, so I don't want it. That's kind of what there you go. So that's how I know. I don't really know until I look at it. Yeah. Until I look at it and I say, is there a number that goes in evenly? That's a perfect square. If the answer to that is yes, then I split it apart. If the answer to that is no, then I don't. So you do have to have a little bit of background as to like, how do I multiply numbers together and get to whatever number I've got? And if you're not like, if multiplication tables are not something that happens like this, which is most of us, right? Then you have the calculator nearby and you're doing exactly what you just did. All right, 24 divided by 2, divided by 2, divided by 4, divided by 5, divided by 6. But really, I don't have to do all the numbers. I just have to do the perfect squares. I'll check all of them and go up to whatever my number is. So like, I'm looking at like 18. All right, so I said, okay, now that's not a perfect square. Let me look at all the numbers smaller. Like, does 16 go in? Does 9 go in? Does 4 go in? All right, look at my list of perfect squares. 2 squared, 3 squared, 4 squared, 5 squared, 6, 7, 8, 6, 7, 8, 9, 10, and so on, right? Those are the numbers that I want to see if they go in. I don't care about anything else. Splitting up my imperfect square is only worthwhile if a perfect square goes in. That make sense?
Yeah.
So having that list nearby is a good idea. Yeah, Sam.
Would you check this out?
We're going to put them up. Yeah, okay. Yeah, we'll put them up. Does anybody that did not get a chance to put one up yesterday have one that they do? Sam, which one do you want?
I'll take number 5.
5 it is. Cool. Anybody else that did not put one up yesterday that wants to put one up today? Okay. Anybody that did put one up yesterday want another one? Jared, pick one.
I'll take 6.
Dave?
1.
10.
I don't think.
So 2, 3, or 4, I think. Go ahead, guys. Go ahead. Pick one, whichever one you want. And then there'll be 2 left for anybody else that wants one. Once you're done, of course, we're not all done necessarily, but that's cool.
2, 3, 4.
Yeah, pick any one you want. Any marker you want. I think, Sam, you're doing
5.
5? Okay.
Yeah.
Jared, you got 6?
Yeah.
Dave, you got 1. Ken, you got 3. Okay, cool. So 2 and 4 are open for anybody else that might want to point back on homework or have to point back on the test. Okay, put your initials next to your work once you're done so I can give you those ones. But this will be it for solving equations today. We'll do some other stuff shortly.
Rosie, I have a question.
Yeah,
So instead of rewriting it, can I just?
absolutely. Go for it. Yep, definitely. Yeah, they're all the way over. I like this whole sitting down, you guys do the work kind of thing. I think I should do. Ken, what are you missing in front?
Oh my goodness.
Anybody, 2 or 4?
I guess I'll give it a shot. I wasn't here yesterday, but I'll go 4.
Anybody for number 2? Probably the easiest one up there, actually. Oh, man.
Oh, good.
There is Brianna.
That's enough.
Emma's.
Yeah.
She sits in the same seat. And she took 3 last classes. There you go.
It's just on. Yeah.
No, that's why I put that one up there, because I knew there'd be some second guessing, but it's actually really good.
Did I do it right, Rosie?
We just took the square root, and this goes for Liam as well. Everything that is correct that's up there, except for one thing that's missing.
Is it just like
Oh, plus.
putting this down or oh?
You too.
Nicely done. Love it.
Maybe before this is not good.
I just have really bad posture, so that's my posture. That too.
Nice. All right. So let's take a look, see how we did. If there's any small changes we need to make, let's make sure that we do those on our own work. Or if somebody else made a mistake, let's see if we can help them out as well. All right. So number 1, this is tape. So square root on both sides. Love it. Plus or minus goes in front, and then right away splits apart the 100 and the -1. Square root of 100 is 10. So we drop the square root, change the number. Square root of -1 is I. So boxed it in. Everything looks good. Right, and it's because this equation we can do that square root to both sides and be safe. And the same thing, puts the square root on both sides. And the only thing that I would do, because this is like the long division symbol,
Yeah. Okay.
that's what makes it the square root.
Okay.
But she's right, the square root of -1 is just I. Like it's a 1, right? It's 1 I. But we don't need the 1, so plus or minus I. Perfect. 3, Kennedy, so same thing, square root of both sides, plus or minus, break it apart. Square root of 35 is not perfect, and it doesn't have any perfect square factors, right? 1 and 35, 5 and 7, I think are the only ways to get there. So there we go. All right, the end, square root ends early enough, perfect, good. Question?
Would you get points off if you did like square root of 7, square root of 5, I?
It's not wrong, it's just more complicated.
Right.
Like, if the answer to a question was x equals 7, would you really put x equals 3 plus 4, right? So let's keep it as simple as we can. 1 square root is better than 2, right? But to answer your question, no, you're not wrong. You're not wrong, but that ends with this class. Like next year, whatever class you would take next year, they would definitely not go. Because the answer is, I don't have to say to simplify at this point. Your middle school teacher said, well, simplify your answers. Well, that's just the way things go now. You always want the simplest answer, and 1 square root is simpler. So, but if you're safe, you're okay. This is Liam. Just so I don't forget. Sweet. Square root of both sides. Plus or minus makes its way in at the end. Sounds good. 23 and negative 1. 23. Not only is there no perfect square factor of 23, 23 is prime. There are no factors of 23 besides 1 and 23. So nothing we can do is split that apart anyway. So we're good just like that. X equals plus or minus square root of 23, and then I. And this goes for both Liam and Jared. My suggestion is to put a little tail on the end of your eye, so it doesn't look like a 1 with a dot on top. Because it can get lost, especially with pencil on paper, because it doesn't show up nearly as darkly as marker or pen. Okay, Sam, number 5, right? So square root of both sides, love it. Square root of 18, not perfect. It's not on that list. So he knows he's got to split it apart. Now, 3 and 6 is definitely a way to multiply to 18, for sure. But let me ask you this, Sam, is 3 a perfect square?
No, I just looked it up when I
Okay, so let's split it apart, but let's choose a different pair of numbers. It still gets you to 18, but pick a number on this list that goes in. What number goes evenly into 18 that's on that list of perfect squares? And so what is the square root of 9? There you go. So you've got the right idea. You just want to make sure that if you're going to choose to split it apart, that we do it with a number that's on that list. So we could just go for it, right? Because splitting it into 3 and 6, okay, that's kind of what Jared did, right? Square root of 3 times square root of 6. It's not wrong. Yeah, my numbers got smaller, but now there's 2 of them instead of just 1. So a little bit less simple, even though my numbers got smaller. The idea is to split it apart so that one number is really, really nice. We can just do it. But good, plus or minus, I at the end, square root ended before you got to the I. Looks great, little tail on the I. So you've got the basic idea down. That's definitely the most important part. And then Jared at the bottom, 125 is not perfect, but 25 goes in. Love it, 25 and 5. So plus or minus 5 on the outside and a 5 on the inside, just kind of coincidentally, and then the I here. Nice. Looks good. I like it. We feeling pretty good? Got it down at this point? Okay, cool. So again, tomorrow you'll see probably 6 more, 2, 2, and 2. So you know what you need to do to get all the points on that section. But the second half of tomorrow's classwork is going to come from what I'm going to teach you here in our last 20 minutes or so. So I don't think you need to go any place like brand new, but we're not going to solve equations. We're just going to put some complex numbers together, okay? Sweet. Okay, so if you have like at least like half a page somewhere, you can probably start your notes there. But if you want to start on a brand new full page, that's cool too. We're going to do operations on complex numbers. We're going to talk about what a complex number even looks like first. Okay, because everything that we've done so far has just had the I, right? But really, this is 0 plus or minus 6i. This is 0 plus or minus 9i. There's a part to a complex number that is just the real part and the part that's imaginary, okay? So somewhere where you have a little bit of space, let's start kind of the next section, I guess, if you will. Here in this complex numbers, on this complex numbers unit, if you will. I know it's like part of 2.4, but 2.4 was super long, so I'm just going to make it like one big section. Okay. Operations on complex numbers. And when I mean operations, I mean let's add them together, let's subtract them from each other, let's multiply them together, let's divide them, let's square them, square root them, whatever. Like let's take those numbers at the end and let's do something with them. I'm trying to figure out how they go together. And I think you're gonna feel pretty natural in why things work out the way they do if you have a decent grasp on things. And so what I want you to see with these complex numbers is that there's a way to write them best. Okay, and that's what standard form is going to be. And like I've been saying back over here, right, this is just the imaginary part, the part that has an I. There's a real part sitting right here That's just 0. Okay? But if it was a 1 or a 2 or a -3, right? It could be like 5 plus 2i or -3 minus 7i. You can have a real part and an imaginary part. And those kind of answers would come from equations that have both x squared and x, where we need like the quadratic formula, or we have to do like -b over 2a and write in vertex form and solve with square roots and stuff. We're not going to actually do the solving. I'm going to jump right to the best version and show you how to put them together. And so standard form looks like this every time. And that's the thing that I need you to start writing down first, is the fact that a plus bi, where a is a number, b is a number, right? Where we've got a real part and we've got an imaginary part, and they're being added or subtracted, I guess, right? Because that b can be negative. A can be negative too as well. And a real part and an imaginary part. Now, maybe a is 0, like all of those over there. A is all 0. Sweet, okay, cool. Still complex, right? Because if you think about the complex number system, we got all these real numbers, right? We've got all these imaginary numbers totally separate. We could add them together and get the complex number system. And again, a number in the real number system is 0. So maybe I just have 5i, 2i, -3i, whatever. Right? The plus and minus is only there because we took the square root. Right? So those are two different answers. I and -i, two different numbers. 9i, -9i, two different numbers. Okay? And that's what we're doing in the complex number system. We're taking real stuff, 5, 12, 2/3, square root 7, whatever, and then adding it to or subtracting it depending on the sign of b. 3i, -2i, 5i. Okay? And the thing that I want to do first, okay, so part 1, if you will, is just add and subtract. We're going to add and subtract complex numbers. And it could be 2 or more. We could have 2 complex numbers being added together. We could have 3, we could have 5. Doesn't matter. The process is all still the same. And I think starting here is going to make it really easy to begin. Adding, subtracting, definitely the easiest, with adding being by far the easiest. But then once we jump up to multiplication and division, it's just a little bit trickier. So we're going to start here. And really what's going to happen is we're going to have 2 different numbers added together. And usually they wrap them in parentheses and says, okay, here's a complex number. Here's another one. Let's add them together. Okay, and so a complex number could look like this. 3 plus 4i. That's a complex number. It's got a real part and an imaginary part. They both happen to be non-zero. That's cool. They could have been 0. They could have been negative, positive, whatever. And then, I don't know, like 5 plus 2i. Maybe that's the next complex number that I want to add together. And so they give us that setup. They say, okay, here's 2 complex numbers. I want you to add them together. And so it doesn't start as an equation to solve. There's no x equals kind of thing like we've been dealing with. We just want to find the best answer for this. And that answer is going to look like this. The stuff without I will go first, and the stuff with I will go second. And maybe one of them's 0. That's cool. Maybe they're both 0, and the answer is just 0. Whatever happens, happens. Let's just put things together that go together. Now, the parentheses at this point really aren't necessary, because adding doesn't change any signs. Subtraction would, so that's why it's super important that we put them all the time just to be safe. But really, at this point, what do you think? Like, what do you think we can do with 3 plus 4i plus 5 plus 2i to make things just simpler?
Just add the real numbers together and the imaginary numbers together.
Okay, so 3 plus 5 is what?
8.
4i plus 2i?
6i.
Combine like terms. That's it. Adding, subtracting complex numbers is just like saying like 3 plus 4x plus 5 plus 2x. Put the numbers together, put the x's together, and you're done. We're going to put it in this order. Right? The real numbers up first, and then the complex numbers up second. And because it's addition and everything's positive, man, that was really easy. The only thing that can make this a little bit trickier is when they start like dealing with subtraction, start mixing in negatives and stuff. So you just kind of want to keep an eye on your signs as you go. And if you're not great with keeping track, grab a calculator and make sure what you're thinking in your mind is what actually comes up, okay? Because what they'll do now is they'll do something like this, like 7 plus 3i minus 4 plus, I don't know, 8i. Two complex numbers, A and B, neither of them happen to be 0. So it is complex for sure. It's got a real part and an imaginary part. It doesn't start as an equation because there's nothing to solve. We're not going to get x equals or anything, like I said. But we are going to have ourselves a simpler version of this answer that just has one real part and one imaginary. And like I said, with number 1, the parentheses weren't really necessary, but they're there just to say, okay, here's a complex number, here's a different one. Here they are crucial, all right? Especially the second one. Because I want to subtract this from this. And we're just going to put them together from left to right. And so let's do that. Let's put the real parts together. If you read it from left to right, I think you'll get it right. 7 minus 4. Remember, the sign in front is the one we want to keep track of. So 3i positive, right? 3i minus 8i.
Negative 5.
3 minus 5. And what a lot of people might find worthwhile is to distribute the negative first. Actually do the subtraction and get rid of your signs, get rid of your parentheses, making sure that everything lines up easily left to right. So that step in red is something that a lot of people like to do, but you don't have to, but it can get a little tricky to keep track of signs, especially if there's like a bunch of negatives all over the place. Because that is how they will challenge us a little bit with this kind of idea, adding, subtracting. Let's do an adding one more time. But it's going to be like negative 2 minus 5i plus, I don't know, 6 plus 2i. If we don't keep track of the sign in front, we might end up like on the wrong side of 0 or putting things together and making things bigger when they're really kind of like whittling each other down. Again, what I think can be really helpful is to get rid of the parentheses. And addition doesn't change anything. So plus 6 plus 2i. You do that, maybe it gets easier. Addition doesn't really make a huge difference, but worth looking at. Real numbers together first. So what's negative 2 plus 6? 4. And then negative 5i plus, the sign in front's all I care about, plus 2i.
Negative 3i.
The last one will be the toughest one. Two complex numbers being subtracted, and there's negatives kind of all over the place. Negative 1 plus 4i minus 5 hold on, can I change this? Sorry, I want this plus to be a minus. Negative 1 minus 4, sorry, because I want to do minus 5. So negative 1 minus 4i minus 5 minus 5. And if you try to do this without breaking the parentheses apart, you definitely can. You just got to really keep a close eye on what's happening, right? Because this set of parentheses doesn't matter. This one does. Minus 5 minus negative, right? Minus negative 5i. Well, what's minus negative? Addition. Plus 5. All right, when I break this apart, this is minus 5 minus negative 5. Right, and when you've got two negatives next to each other, put them together to make a plus. That should make it a little bit easier for us to put things together. So what do you think? Negative 1 minus 5?
-6.
Right, starting at -1 and subtracting 5 more. It's going to move them left and right along the number line. And then -4i minus -5i, -4i plus 5i. 1i, better known as I. Good. And that's really it. Like, I mean, I could do like 3 of them being added together. You just put all the real parts together, put all the imaginary parts together. You have like 5 things all being subtracted. Just get rid of your subtraction, take care of your parentheses and put stuff together. So maybe I'll push you a little bit on that tomorrow. But that's it. That's adding subtraction. Do have a little bit of time, which is good because I wanted to get to multiplying today. So we'll do that one next. But anything 1, 2, 3, or 4, if you don't overthink it, you're going to get it right. If you try to make things more complicated in your head, that's where you're going to mess up signs. That's where you're going to put things together that don't go together necessarily. So be careful. Be careful. Okay. Let's challenge ourselves just a little bit with these last 10 minutes or so. Adding, subtracting, done temporarily. Right? Let's move up one level. Okay? And let's take a look at what it's like to multiply 2 complex numbers. Okay? So I'm going to erase all this stuff here, and I'm just going to do maybe 1 or 2 at the most, probably 2 if we can, where 2 complex numbers are right next to each other being multiplied together. Okay, so the sign in between is not going to be a plus or a minus, right? It's going to be times. Okay.
Oh, no.
See, right, so I don't want to erase it.
Just erase everything except for the 4 part. I'll take it that one. Thank you.
All right, so next level up, if you want to, put a little title, multiply. Okay, how do we multiply complex numbers? Well, I think once I set it up, and then I give you juxtaposed next to that a very similar kind of looking thing, I think you'll have a pretty good idea of what the complex version is going to be like, knowing what we want to get to that a plus b. Okay. And of course, you see a and b coming up again because those are just 2 numbers, could be whatever we want. Okay, so here we go. Number 1. I don't know. Let's keep the numbers small. Let's go like 2 plus I times
4.
4.
Yeah.
Cool. Plus
6i.
too big, a little smaller.
3i.
3i, sounds good. That's what I was thinking. Perfect. Now, I think what's going to make this easier. So we don't start here necessarily, but instead we start here. 2 plus x times 4 plus 3x. Let's do that one on the right first. Right? Instead of I, it's just x. And now, how do we do that? We've got 2 things in here. We got 2 things in here. And we're trying to multiply them together. How do you multiply a binomial times another binomial?
You can't mix them.
Well, I can't do like 2 times x because they're attached by plus. I can't do 4 times 3x. Those are attached by something else. But like I want like all of this times all of that.
Multiply like things?
No, because then we might be missing out on some things that are happening. We can add and subtract like terms, but this is multiplication. You got to do the multiplying part first. How do we multiply things together? Going back to like almost like Algebra 1 kind of stuff, or even like quadratics in Algebra 2.
You multiply by like everything?
Yeah, everything from the first gets multiplied through everything from the second. So this 2 right here gets multiplied into the 4. We'll see what we get. It's multiplied into the 3x. We'll see what we get. Okay, so that 2 is good because I multiplied through everything here. This x has got to get multiplied through the 4 and into the 3x. All right? And so we have 2 things here and 2 things here. What's 2 times 2?
4.
How many arcs did I just draw?
4.
So we're good. That's how many terms I should end up with once I'm done. And of course, hopefully, fingers crossed for stuff we can put together to make it go from like 4 terms to 3 or to 2 or even to 1, kind of depending on what we've got. But that's the strategy of multiplying stuff together. So let's do it. Let's go with the 2 first into everything. What's 2 times 4?
8.
Sweet. That's the easy one. Good. 2 times 3x. Nice. Numbers with numbers. All right, 2 times 3, and x with nothing. There's no other x to go with it. It's positive, so I'll connect with addition. So plus 6x. Takes care of the 2. Now we got to do the x. X and positive x is connected by addition here. So sign in front matters. So x times 4.
4x.
Positive, so let's use a plus. And then x times 3x.
X to the power of 2.
So numbers with numbers, x's with x's. What's this number right here?
1.
So 1 times 3,
3.
and then x times x?
2x. Squared.
X squared. Good. When we multiply variables together, we add their exponents. 1 and 1 is 2. My properties of exponents. There they are. 1, 2, 3, 4 of them. Good. I have 4 arcs. 2 times 2 is 4. Everything matches. I got 4 terms. Now I can start settling in and trying to figure out, okay, what can I do to make it look simpler and nicer? Do you see anything there that goes together? Do we have any like terms?
6x and 4.
Yeah. If you want to know if it's a like term, cover up the numbers. If you're looking at the exact same thing, you can add them together. Cool. So 8 is the only number by itself, cool. But then 6x plus 4x, what's that? 10x, sweet. And this is the only x squared term, so that's going to stay the same. And then standard form says put the biggest exponent first and then go down from there. And that's the best we can do, right? That's the best version of that answer. We put all the like terms together, we wrote it in standard form for whatever kind of equation, whatever kind of expression it is, in this case quadratic, put the x squared, then the x, and then what you're going to see with complex numbers is the process is identical, but there's actually more we can do to make it look even simpler. Because we know what we want to get to. I know what my goal is, and that's a plus bi. This is what I want. I want it to end up, once I'm done, it better look like that. So let's do the same thing. Everything from the first gets multiplied through everything from the second. 2 things in the first, 2 things in the second, 4 things I should get. There's 4 arcs there. I think I'm good. And the way we multiply numbers with x's and x's with x's have the same exact mindset going into I. And let's just go one at a time. What is 2 times 4? Yeah. If 2 times 3x was 6x, what's 2 times 3i?
6i.
Positive, so I'll use plus. If it was negative, I'd use minus. Okay. X times 4 was 4x. So what's I times 4?
4i.
X times 3x was 3x squared. So what's I times 3i?
4.
Numbers with numbers. X's with x's. 1 times 3 was 3. X times x was x squared.
3i squared. Okay, sorry, that threw me off because I thought, like, in front of the first I, there was going to be like a 1.
So there is, but since we're multiplying things together, we multiply the numbers and we multiply the I. So 1 times 3 is still 3. If we were adding, like 1i plus 3i, then definitely 4i.
Okay.
But the exponent can't change when we're just adding, right? This didn't turn into 10x squared. We just combined the coefficients, right? This changes to x squared because we were multiplying. So same thing here, right? I times 3i, 1 times 3 is 3, I times I squared. Okay, what do you see that we can put together?
6i, 4i.
11. All right, so of course, just like the x's, that's going to be 10. So what about this? Our goal is to just have an I. I don't want an I squared. Right? I want just I. And if every complex number can be written like that, then there must be something we can do with that I squared. Well,
Yeah.
it's not an equation that has like a left side and a right side, like we've been doing for the last couple of days, where I can do something to the left and to the right. I'm just simplifying, or I'm just multiplying things out. I'm not really solving an equation. So if I square root that, I'm changing it. And I don't want to do that. I want to simplify it by writing it better. Just like 4i and 6i is 10i, that's better. Not different, it's just better. And so it's really the only thing that is the problem is I squared. There shouldn't be one when I'm done. So what is it? What is I squared? Close. If I is the square root of negative 1, what's I squared? This takes us back to Friday when we first saw this.
One.
-1.
I squared is negative 1. Look back 2 days ago to your notes. Remember we did that little circular thing, right? I squared, I to the third, I to the fourth, and around it went. Right? I is I. I squared is negative 1. I cubed is negative I, and I to the fourth is 1. We can always reduce these powers. And here's what that means. That means that this right here is negative 1. I is the square root of negative 1, which means that I squared is negative 1. And if I have an I squared in my problem, why leave it when I can make it way simpler? And so what's 3 times negative 1? So minus 3 instead. Now what?
You have to do 8 minus 3.
A plus bi. And what's so nice about this is that we can jump right to here the faster we get more comfortable. Because all I squared is going to be is multiplied by negative 1, which means the number doesn't change, just the sign. All I'm doing is multiplying by negative 1. And all that's going to do is going to keep this number the same, and it's going to change it from positive to negative, or maybe from negative to positive. That's good. I'm good right there. I will definitely need to reteach the multiplying stuff when I get back on Thursday. But for tomorrow, you'll see some solving equations, and we'll do some adding and subtracting. Okay, I will leave with the sub, whatever it is, probably like right there on that desk nearest the door is going to be rosters and the classwork for him or her to hand out to me. Okay, I'll put a spot on Canvas for you to upload it. Okay, be wonderful to whoever this person is that is subbing a high school class in May. Godspeed to them for doing that. But so thank you for your continued respect, no matter who's in the front of the room, and your general timeliness getting to class. Okay, I will see you on Thursday. Have a good day. See you guys.
Do you want us to write it 10i plus 5, like just to make it neater?
A plus bi.
Oh,
Real number
so
first,
keep it.
imaginary number second. That's standard form. Yep.